Part 2 of your trapezoid lesson goes with this worksheet. We just took notes on using the formula for area of a trapezoid. What I want you to understand is how all these things fit together. So the definition for a polygon is just a closed figure with all straight sides. I mean, roughly speaking, there's infinite kinds of polygons. Like a triangle is a polygon that has 3 sides, right? A quadrilateral is right here, and it has 4 sides. You could do a pentagon, which has 5 sides. You could do a hexagon. You could do a dodecagon, a 100gon. It has 100 sides, whatever. There's infinite polygons out there. I want to talk about the quadrilaterals specifically because I feel like over the course of your school careers, you've missed out on a really great piece of information of how quadrilaterals all fit together. So I'm going to do this in the form of a family tree. So in your family tree, there are people who came before you, your forefathers, your ancestors. You look like a little bit of them. Maybe, you all have blue eyes, or some have brown, or some have a specific nose, or your ears, or whatever, your heights. Everyone's tall in my family, everyone's short. So polygon gave quadrilateral one of its traits, and one of its traits is it has all straight sides. That's what it got from really its forefather here, right? But quadrilateral has to be a little bit different or it would just be a polygon. So not only does it have straight sides, now it has 4 sides. That's what differentiates it from its infinite brothers and sisters. So polygon would be like your great-great-great-grandfather who had infinite children, one of them being quadrilateral. We're going to follow this family tree. Everybody that comes after quadrilateral in this family tree has 4 sides. 4 sides, 1, 2, 3, 4, 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 4 sides, 1, 2. They're all quadrilaterals. Now, quadrilateral goes ahead and has 2 children. Each of these 2 children will take on the trait of polygon. They each have 4 sides. And they each have 4 sides like quadrilateral, and they each have straight sides like polygon. So they're each polygons. They're each quadrilaterals, but they also have to be called something different. So here we have trapezoid. And trapezoid says, I'm going to have 1 pair of parallel sides. I'm going to have 4 sides. I'm going to be completely closed in, but I'm going to have 1 pair of parallel sides. Over here, we have kite. And kite says, well, I'm going to have all closed in. I'm going to have 4 sides. And I'm going to have adjacent equal sides. It's really 2 pairs of adjacent equal sides. So this is equal to this. They're adjacent. Adjacent means next to. And this is equal to this. That's what makes it a kite. Anything that has sides next to each other that are equal, like this, they're going to be called a kite as long as they have 4 sides. So 4 sides and sides that are equal. Now, so trapezoid has an actual special type of trapezoid here. We kind of just talked about it. So that's the 1 pair of parallel sides, but this one's actually an isosceles trapezoid. Isosceles means it has an opposite equal pair here, just 1 pair. So an isosceles trapezoid says I'm going to be a closed-in figure. I'm going to have 4 sides. I'm going to have 1 pair of parallel sides, but these 2 opposite sides here are going to be equal. This is also a trapezoid, but it's not an isosceles trapezoid. Isosceles trapezoid has a child. Going to be a figure with all straight sides, just like great-grandfather polygon. Granddad quadrilateral is going to have 4 sides. Just like trapezoid, it's going to have 1 pair of parallel sides. But just to be different, it has to have something different. It's going to say, I'm also going to have these 2 sides be parallel. That's why we call this a parallelogram. It has 2 pairs of parallel sides, and it's a quadrilateral, 4 sides. All parallelograms have opposite equal sides and opposite equal angles. We're not really going to get into a ton about the angles, but this angle is equal to this angle. This angle is equal to this angle. You'll notice I use a little arc here and 2 arcs here, just like with parallel sides, 1 arrow, 2 arrows. It's kind of a geometric thing. So again, as we go down, a parallelogram is also a trapezoid, is also a quadrilateral, is also a polygon, but not all polygons are parallelograms. Some polygons are triangles and some polygons are hexagons. So this is a special type of polygon, a special type of trapezoid, a special type of quadrilateral. So what's funny here is the area formula for a parallelogram, we just put it in our notes, is base times height. So anything that comes after it, which is also a parallelogram, this formula is going to work for it. A parallelogram has 2 kids. They have all the traits that came before, but they also have to be a little bit different. So this is going to be rectangle. So just like parallelogram, opposite parallel sides. Just like trapezoid, 1 pair of parallel sides. Just like quadrilateral, 4 sides. And just like polygon, all straight sides. Also, just like parallelogram, opposite sides are going to be equal, but because we have 2 pairs of parallel sides, they just become 90-degree angles. So they still follow that parallelogram rule, except now, instead of its 2 different measurements, they're all 90 degrees. They have 4 equal angles as a result of that choice. Over here, said, well, you had 4 equal angles. I'm going to have 4 equal sides. So this side is equal to this side is equal to this side is equal to this side. Just like parallelogram, these 2 sides will be parallel. These 2 sides will be parallel. But now all sides are equal. Just like trapezoid, it's 1 pair of parallel sides. Just like quadrilateral, it's 4 sides. And just like polygon, all sides are straight. Now, just like parallelogram, this side is this angle is equal to this angle, and this angle is equal to this angle. You won't be tested on the angles, but that is something geometric. Here's where it gets interesting. This is called a rhombus. The formula for the area of a rectangle is area equals base times height. That's in this unit. Well, it's because it's a parallelogram that works. And the formula for, as you've probably guessed, a square can be area equals base times height. That works as well because a square is a rectangle. A square is a rectangle, but not all rectangles are squares. A square is a rectangle. A square is a parallelogram. A square is a trapezoid. A square is a quadrilateral. A square is a polygon. A square is also a rhombus. So the traits of these 2 are all given to this bottom one here. It has all straight sides like polygon. It has 4 sides like quadrilateral. Just like trapezoid, it has 1 pair of parallel sides. Now, like parallelogram, it has 2 pairs of parallel sides. Like rectangle, it has 4 equal angles. Like rhombus, it has 4 equal sides. So it takes on the characteristics of everything that came before, and now it's called a square. It's a parallelogram of 4 equal angles and 4 equal sides. Now, if you carry this over, I missed this because it's not a 6th grade standard, but all rhombi are also kites because you have adjacent equal sides, and adjacent equal sides. So this square is also a rectangle, is also a rhombus, is also a parallelogram, is also a kite, is also a trapezoid, is also a quadrilateral, is also a polygon. But most specifically, it's a square. And although you can use area equals base times height, many people will simplify that down into side squared because if that is side and that is side, and they're at a right angle, which makes them the base in height, that makes base equal to height, and that would be side squared. That's just a little thing on how all this works together. Now, the big question is, will I be assessed on this? Currently, you're going to be assessed on finding area of a parallelogram, area of a rectangle, area of a square, and area of a trapezoid. But I think it's interesting to know how these all fit together, and that helps you to understand some of the geometric stuff. Now you're going to be able to move on to your homework.